Hi students, previously we observed the conceptual analysis of hydrogen spectrum, and now the the important methods where we are expecting the question based on this spectrum, that is regarding the comparison of wavelengths. Means, see for example, suppose if you observe Balmer series. See for here, this is the diagram for Balmer series, where n equal to 2, and this is first line, and it is second line, third line, and so on we are having. See for example, this is H alpha line, and it is H beta line, or H gamma, or H delta, like that. So, one important model here, what we are expecting, they will give one wavelength and you have to find out another wavelength with respect to the Balmer equation. So for that, just I am giving a simple example. See, if you understand this analysis, we can compare the wavelengths among any two lines. Means two lines in same series, two lines in different series, two lines in different atoms, because we are having Z in that general expression. So for that, first of all, once again, I will give the Balmer equation. That means wave number nu bar, that is nothing but 1 by lambda, which is equal to R into 1 by n1 square minus 1 by n2 square into Z square. So that is Balmer equation. So you should keep that expression in your mind. Now, here, by considering Balmer series, we are going to compare the wavelengths of first two lines, that is H alpha and H beta lines. So for that, imagine, suppose in Balmer series, here as example I am giving, for example, Balmer series. In this, if wavelength of the first line means H alpha line. So for H alpha in Balmer series of hydrogen atom, imagine its wavelength, let it be lambda alpha, because there is alpha line, it will be, for example, x angstroms. They are not giving the value, they are going to ask the general expression. So we are considering that wavelength of first line in Balmer series of hydrogen atom, that is as x angstroms. Now, if it is like that, then what about the wavelength of H beta line, lambda b, with respect to that wavelength of H alpha line? So this is one standard model. So now once again be clear about the question. They are giving wavelength of first line in Balmer series as x angstroms, and you have to find out wavelength of the second line. It may be third line or fourth line. And one more point, sometimes they will give the wavelength of first line in Balmer series, and they are going to ask the wavelength of first line in Lyman series. Yes, that is possible. For that only, just to understand how we have to compare these two wavelengths. So for that, if you observe that solution, see first I am going to give the general expression for wavelength of first line, means here 1 by lambda alpha, that is equal to, as per that equation, R into, now see that, since it is Balmer series, for first line, n1 equal to 2 and n2 equal to 3. So that means 1 by 2 square minus 1 by 3 square. So now here it will be 1 by 4 and it is 1 by 9. So on overall, it will become 5r by 36. That is 1 by lambda. So therefore, wavelength lambda equal to 36 by 5r. That is equal to x angstroms as per the given information. So like this, first go for the general expression for the wavelength. In the same way, here we have to find out the general expression for second line, means H beta. So for that, 1 by lambda beta, that is equal to R into 1 by n1 square, means 2 square minus 1 by N2. For second line, what is N2? 4. Means 4 square. So now that is nothing but 1 by 4 minus 1 by 16. So on overall that will becomes 3R by 16. So here it is 3R by 16. So according to this, wavelength of that line beta, that is nothing but 16 by 3R. So like that we are getting the general expression. So after that, since we know wavelength of first line and we have to find out second line, so finally wavelength of alpha line by wavelength of beta line, that is equal to, now substitute this expression, 36 by 5R by means into 3R by 16. So now here R is going to be cancelled, and after that if you observe this 4 and it is 9. So total it will becomes 27 by 20. But the given value for wavelength of alpha line, that is x. So that implies here x by wavelength of beta line, that is equal to 27 by 20. Therefore, wavelength of beta line, that is nothing but 20 by 27 x angstroms. This is the answer, and it will be as one of the options. So like that, this is one standard model. So like this, between any two lines, we can compare the wavelengths. So be clear about the approach of this type of problems. First, go for the general expressions for the wavelengths of the given two lines. After that, you have to go for ratio. Then automatically you will get the wavelength of the required line. So this is one standard. And another one, in the same hydrogen spectrum. Here, how to find out the number of lines that we are able to get during the de-excitation of the electrons. So for that, mainly we are going to consider the number of lines in two ways. So now, number of lines in emission spectrum. For this, for example, see, this is the ground state, n equal to 1, and we have the excited state, let it be nth level, for example 7th level. Now, if electron excited from 1st to 7th, during its de-excitation up to the ground level, the number of lines that what we will get means, here the question, suppose if electron was excited to nth level. So in that condition, during de-excitation, the number of lines, that is equal to n of n minus 1 by 2. N of n minus 1 by 2. Where n is nothing but the excited state. See, for example, suppose electron was excited to nth level. For example, if n equal to 7. So therefore, in de-excitation, number of lines, that is equal to n of 7 into 7 minus 1, 6 by 2. That means 21 lines. So during its de-excitation, we are going to get 21 lines. So this is one model. But here one thing you have to remember, we are considering the de-excitation up to the ground level. That is the meaning of this formula. And there is another one. See, for example, from the same 7th orbit, if electron is going to de-excite into second one only, means de-excitation is confined to second orbit. It is not coming to the first. So higher level will be considered as N2 and lower level will be considered as N1. So for that, the next formula, what we are having. Suppose if de-excitation or the electronic transition is between N2 to N1. Here N1 may be 1 also sometimes. If N1 equal to 1, we have formula N of N minus 1 by 2. But in this situation, number of lines, that is nothing but N2 minus N1 into N2 minus N1 plus 1 by 2. Or we will consider one more formula here, that is nothing but sigma N2 minus N1. So like that, here we have to use this one. See, the same example means the de-excitation is between, or the electronic transition is between 7 to 2. As per this formula, number of lines, 7 minus 2, this is N2 and it is N1, 7 minus 2, 5, into 5 plus 1, 6 by 2. So that means here we are going to get 15 lines. See the difference. If de-excitation is from 7th to 1st, total number of lines are 71. If de-excitation is between 7 to 2nd, total number of lines what you are expecting, that is 15 only. So like this we have to use this expression. Or otherwise, sigma means as per sigma N2 minus N1. 7 minus 2, that means 5. So here as per that, if you observe that formula, there also we are getting total number of lines as 50. So that is the way how we have to consider the number of lines. Of course here no need of this one, directly we can go for N2 minus N1 into N2 minus N1 plus N plus 1 by 2. So like this you have to find out the number of possible lines in emission spectrum during the de-excitation of the electron. And another concept, another important point here, see, for example, there are 5 hydrogen atoms. This is, imagine as a hydrogen atom, we have 5 atoms. In all those 5 atoms, we are having 5 electrons. So all the 5 electrons, they excited to 4th or 5th orbit. This is a ground state and it is excited state. Now, if all the 5 electrons are de-excited, how many lines that we are going to get? Generally, since 5 electrons are there, we used to feel that as 5 lines. That is wrong. Because all the electrons are excited into same orbit. So, from this at once they are de-exciting. So, that is, by each electron, the energy released is same. So, we are going to get only one line. But the brightness of the line will be more. So, as far as the question, if they are giving regarding the number of atoms, for example, 100 atoms. In all those 100 atoms, here electrons are excited to the same level. So then the number of possible lines during de-excitation, that is only one. Suppose if there are 2 types of de-excitations, 2 lines. 3 types of de-excitations, 3 lines. So for that, even though we have 1000 atoms, for example 1000 atoms, in all those 1000 atoms, electrons excited to 7th orbit and at once they are de-exciting to 1st level. Just we are going to get only one line with the maximum brightness. So that is, here there is no formula, just we have to remember how the de-excitation, in how many steps the de-excitation is going to take place. But please remember the brightness of the line will be more. That is another concept. And finally, as far as number of lines concerned, see, sometimes electron, suppose it is in 7th orbit and this is first one. In its de-excitation, the number of lines that are able to exist in Balmer series, they are not asking the total lines. In a specific series, how many lines are possible if electron was excited to 7th? So for that purpose, here the formula, number of lines in a series, Just remember, this is all in view of de-excitation. I think I am not referring that point every time. During de-excitation, we are getting the lines, that's all. So number of lines in a series, that is nothing but N2 minus N1. N2 minus N1. See how to understand that. Suppose if 7th to 1st, if it is going to de-excite, already we know that we are going to get 21 lines. Among the 21 lines in Balmer series, means in visible region, how many lines are possible? For that, this is 2, 3, 4, 5, 6 and 7. Now how the de-excitation takes place? 7th to 2nd, yes, that is one possibility. 6th to 2nd, another possibility. 5th to 2nd, 4th to 2nd and 3rd to 2nd. That's it. Because the question is related to only the number of lines in Balmer series. So now see how many lines are possible? 5 lines. Now what is N2? 7. What is N1? 2. N2 minus N1. 7 minus 2. 5. So that is the meaning of this formula. So in any series, how many lines are possible if electron is de-exciting from higher level? That is nothing but N2 minus N1. So that is regarding the objective analysis related to hydrogen spectrum. And finally, once again, I am coming to Balmer series. See, as far as Balmer series is concerned, in this Balmer series, once again, try to recollect the diagram. First line, so this is N1, let it be 2, and higher levels. This is H alpha, H beta, H gamma, H delta, and H infinity like that. So now, imagine this is H alpha, and it is H beta, H gamma, and H delta. If you recollect the wavelengths, it is around 6563 and it is 4101. Means from H alpha to H delta, the wavelength is going on decreasing. That too, they are forming in visible region. So that's why we are always getting H alpha line at red end. This is at red end. And if you observe that H beta, H gamma, H delta, in this direction, it is moving towards violet. So we are getting H alpha line at red end, whereas H delta line at violet, because energy is more and here energy is less. So in Balmer series, the variation of those wavelengths from first line onwards is from red end to violet end of visible region. So like that, how the variation is going to take place in that visible region. So this is another point as far as Balmer series. And finally, the importance of the spectrum. Of course, the importance of line spectrum is as like our thumb impressions. No two persons will have same type of thumb impressions. Similarly, no two elements or atoms of the elements are going to give the similar line spectrum. Means the line spectrum of an element is unique. So because of that, some of the elements they identified with the help of spectral analysis like helium, rubidium, cesium, gallium, indium, thallium, scandium. These are all the elements that were discovered by the spectral analysis. So that is enough as far as the spectrum concerned. So be clear about the each and every formula, and I hope that you will be sure to answer the questions by having this information with you. Thank you.